What is the difference between a good conductor and a good insulator? Conductors allow their electrons to move freely, whereas insulators have tightly bound electrons that do not allow them to move freely. Why are metals such good conductors? Again, right like 16, because metals allow their electrons to move around freely. Why are materials such as rubber and glass such a good insulator? Again, it's about the tightly bound electrons. The electrons in insulators do not move around freely, which means they don't allow charge to move freely through them. Number 18, what's a semiconductor? Semiconductors are materials that can be either an insulator or a conductor depending on how you work them. They can be rearranged, the particles themselves, they can be heated and tempered and changed in ways that allow them to do both. Either or, really. What's a superconductor? Well, not to be foolish, but it is a thing that is super at conducting. They have, as they would say, nearly infinite conductivity or nearly zero resistivity. There's no resistance, there's infinite conduction. And so they are super at conducting. What are the three main methods of charging objects? Now, this is where your book and I say something different. And so I want to show you right here on the previous page. In summary, we know objects can be charged in three ways. Number one, friction. Electrons are transferred from friction to one to the other. By contact, when electrons are transferred from one object to another without rubbing, charge rod placed in contact with metal will transfer it to the metal. And then by induction, that's without touching. That's charging without touching. Now, then they do also talk about polarization. So the book says friction, contact, and induction. I say friction and contact are the same thing. Induction and polarization are what I say the answers are. So be wary of test questions that ask for which one is and which one isn't. The book will be looking for friction, contact, and induction for the answer, whereas if it's an essay question, I much prefer you to talk about polarization. I think it's very important. Okay, which method involves no touching? 20B. That would be induction. So next, what is lightning? Lightning is a static buildup of electricity in the clouds. The clouds will often build up a negative charge, and often if you're talking about lightning between the ground and the clouds, you will get a positive charge on the ground. That's because of polarization, and then nature doesn't like imbalance, and so it has to discharge. You can have lightning that occurs from cloud to ground, and you can have lightning that occurs from cloud to cloud. You can have both. It can happen, in both combinations there. What is the functioning of a lightning rod? A lightning rod gives a very convenient path for electrons to go from the lightning into the ground and then be canceled out. Imagine if lightning was trying to strike in a very, very flat place, maybe out on the lake. There's no particular place where the positive charge is building up out over the lake, so lightning just kind of hits any old random place. But if you have a sailboat out there on the lake, all of a sudden there's a tall place for those charges to build up, and charges tend to build up at pointy locations. And so all of a sudden it's been known amongst sailors that you'll see these little crackles of electricity before an electrical storm. And that's because the positive charges are conglomerating, they're gathering up at the top of the mast, and lightning will often crack down on that. Now, on tall skyscrapers, buildings, barns, and whatnot, they have a lightning rod attached with a wire that goes into the ground, literally to the ground, and it grounds it out. And that allows it to not electrocute everything around it, and it gives it a channel to go into and not ruin things. What does it mean to say an object is electrically polarized? That means it's an object like water, where the oxygens and the hydrogens do not share the electrons equally. They do not share the electrons equally. So in the water molecule, hydrogens are, they give it up. They give their electrons away. They are more positive side, whereas the oxygens are hogs, and they are the more negative side. When a charged object polarizes another, why is there an attraction between the objects? Now, for an example on this, Imagine our little video we watched with our Russian friend up in the ISS. He had a charged up plastic bag and just a blob of water. There's nothing special about the water. But it was attracted because the positive plastic was attracted to the negative oxygen in the water. It didn't change the water in any way, it just aligned it so that the negative side of the water molecule was attracted to the positive plastic. And what's an electric dipole? Well, just like we just talked about, is a molecule that has a positive on one end and a negative on the other. Two-pole dipole. All right, into the Think and Explain section. Think and explain. If you scruff electrons from your hair onto a comb, from your hair onto the comb, are you positive or negative? Well, if the electrons went from your hair, they left, meaning they left you positive. What about the comb? It is therefore negative. Then we went down to 7 through 10. 7. Why is a good conductor of electricity also a good conductor of heat? Well, you got to think about what's happening there. Electron transfer is what electricity is about. Well, you also have electrons tend to carry electricity through a material as well. The movement of those electrons allow it to heat up. You know, that's not to say that if you have an oven mitt that it never gets warm. That means that the molecules themselves don't transfer the electrons around easily. Explain how an object that is electrically neutral can be attracted to an object that is charged. Imagine you've got your balloon and you charge it up on your sweater. And then you hold that balloon over top somebody's hair, and this somebody is not charged up. The hair is neutral, but the balloon is, let's say, negative. Well, the negatives on the balloon attract to the positive parts of the hair molecules. That's how it can be attracted, because that hair is polarized. If the electrons are positive and protons are negative, would Coulomb's law be written the same or differently? It would be exactly the same. Positives and negatives in this regard are labels only. They mean nothing other than these are opposite charges. And then, 5,000 billion freely moving electrons on a penny repel one another. Why don't they go flying off the penny? Well, because not only are there electrons, but there's also 5,000 billion freely occupying protons. And those protons attract the electrons. That's what holds matter together. It's the attraction of electrons and protons, and it's all a big balancing act. To steal an electron from an atom is actually really difficult. Nuclear forces are very, 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 very strong. So I hope this was a useful experiment for you, and you learn from it, because tomorrow you have a test. Good luck.